It is my pleasure to introduce you to your speaker, Serhii Seletskyi, who is the head of architecture at Intellias, who are a recently appointed platinum level corporate member of the IoT community, and we're very proud of that fact. And by way of his experience, he's really focused on helping enterprise companies harness the right kind of technology and the right kind of architecture to scale business and also make it future-proof. And he's got a lot of deep domain expertise in architecture, microservices, cloud-native development, and really the work he's doing at Intellias is pretty profound, and he's working with his team to successfully deliver and optimize and scale IoT and IoT software solutions for things like smart cities, smart buildings, connected cars. So this is a really high-end, high-level conversation that we're thrilled to have here at IoT Day Stuff. So Serhii, without any further ado, let me turn the floor and the stage over to you, sir.
Thank you for a great introduction. Welcome everyone. Thank you for joining us today. So I'm Serhii Seletskyi, head of architecture and also industrial IoT practice leader in Intellias. So Intellias is a leading global service provider for companies to help with building next generation technologies. We are on the market for 20 years already. Personally, I involved in IoT industry for the last 15 years, and my current role in Intellias as was told to provide IoT consulting services for our customers. Today, I will be talking about how we transform manufacturing business of our customers with help of industrial IoT digital twins technology. My hope is that by the end of this meeting, you will get valuable insights on impact of IoT digital twins technology for your business. For some of you, this might be your first exposure to industrial digital twins. For others, this may build on top of you already know. My hope is that everyone can live with some knowledge that will enable to be more productive in your day. Our discussion is scheduled to last about 45 minutes. My presentation should take around 30, leaving us with enough time for Q&A at the end. So let's begin. In traditional manufacturing processes, manufacturers face a range of challenges, such as long development times, high costs, and inconsistent product quality. This can lead to delays, inefficiencies, and lower profitability. Additionally, as manufacturing becomes increasingly complex and interconnected, it can be difficult to identify and address issues before they become major problems. IoT digital twin technology can help address those challenges by providing manufacturers with a virtual replica of their physical manufacturing process. This technology allows manufacturers to simulate, monitor, and optimize their operations in real time, reducing development times and cost, improving product quality, and increasing productivity. By utilizing digital twins, manufacturers can also identify potential issues before they occur, allowing them to take preventive measures to avoid costly downtime and disruption of the process, improve efficiency, reduce cost, and enhance product quality overall, resulting in increased profitability of a company and competitiveness on the market. Unfortunately, enterprise-grade IoT digital twin solutions are very complex that involve multiple interconnected devices, sensors, networks, and applications. Here is a typical blueprint of solution architecture we implement for our customers. It includes edge computing that involves processing big data locally on the edge devices, such as sensors, gateways, instead of sending every operation to the cloud. This approach reduces latency, increases efficiency, and ensures real-time responsiveness, making it ideal for real-time monitoring and control of production process. Edge computing also enables integration of legacy SCADA systems and devices, enabling to leverage their existing infrastructure while implementing new IoT solution. As for the cloud aspect of the solution, the level of complexity significantly increases there, as we need to ingest large amounts of data to be stored, processed, and analyzed. This requires robust data management capabilities that can handle both structured and unstructured data and provide real-time insights of the system performance. Achieving interoperability in such a complex system requires standardization of protocols and interfaces, as well as compatibility between different hardware and software components. Security measures needs to be implemented on all levels of a system, from the devices and networks to the third-party application integration with our platform. Building an enterprise-grade IoT digital twin solution can be costly, as it requires investment in hardware, software, and skilled personnel. Additionally, maintenance and support costs can be significant, especially for systems that deploy at scale for multiple factories. The main issues includes, of course, managing large volumes of data, as average factory generates about 50 terabytes of data annually. Achieving scalability and managing costs are very hard. Addressing these challenges requires us to build a framework that enables efficient management of big data and ensures scalability while keeping costs under control. This framework, based on latest developments of Microsoft Azure IoT platform for digital twins, and is designed for meeting specific needs of specific manufacturing facilities and factories. With our framework in place, we can leverage edge computing to enable real-time monitoring and control of production process, leading to increased efficiency and productivity. So let's deep dive a bit on how the digital twins tackle those challenges. Every object in this world will soon have a digital twin, whether you want this or not. In manufacturing, IoT digital twins can be used not only to monitor the performance of production environment, identify maintenance needs, and optimize production processes. Nowadays, its usage applied in many areas, including design and planning of manufacturing facilities to reduce construction cost and improve factory throughput while keeping costs the same or even lower. In combination with AI, IoT digital twin makes informed decisions and reacts faster than any human to resolve equipment failure, change a supplier, or shut down unsafe factory line, for example. IoT digital twins is not just a fancy 3D visualization. It is a powerful ecosystem that enables organizations to optimize their operations and transform their manufacturing process by creating a virtual representation of physical objects, systems, processes, and overall organizational structure, identify issues and inefficiencies in these processes, and simulate scenarios to test potential solutions. This leads to more informed and automated decision-making, improved productivity, and better adaptability for changing market needs. So IoT digital twins offer significant benefits to organizations looking to improve their operations and stay ahead of the competition. So let's look how we model such a complex digital twins. There are three main approaches to modeling IoT digital twins visualizations. First one is BIM import. This approach involves importing data from BIM system about construction projects and equipment into the IoT digital twin solution. Second one is CAD design from scratch. This method is typically used for a simple manufacturing process where BIM is not well maintained. And last but not least is 3D scanning. In this approach, physical objects and spaces are scanned using 3D scanning technologies like Autodesk Reality Capture to create digital representation. This method is useful for retrofitting existing structures or creating a digital twin of specific physical objects that has no CAD model yet. Each of these approaches has its own advantages and disadvantages, and the choice of approach depends on specific needs of the project. Regardless of approaches used, modeling industrial digital twins, visualizations requires expertise in 3D modeling, data science, and domain-specific knowledge of manufacturing industry. The most popular and cost-effective scenario of building digital twin visualization is BIM import. And right now, Autodesk is an industry leader in this segment, allowing seamless integration on all stages of factory construction. IoT digital twins can enable advanced simulations of construction projects, leading to improved project delivery and outcomes. This can enhance decision-making capabilities for construction teams as well, as they anticipate and optimize project performance using simulated digital twins data together with BIM to get more data insights. Additionally, IoT digital twins can enable better collaboration between different teams and stakeholders, ensuring that everyone has access to the latest data and insights. Depending on the specific BIM 360 product, offering IoT digital twins can be leveraged to improve construction documentation, planning, and operation of factory building, etc. Overall, IoT digital twins can enhance and play a crucial role in the capabilities of Autodesk BIM products and improve outcomes of construction projects. So, how we integrate these two complex and different ecosystems? Fortunately, Microsoft and Autodesk has collaborated already for a couple of years to integrate Azure IoT Digital Twins with Autodesk Forge API platform. This integration enables developers to build IoT applications that leverage both IoT data and Autodesk immersive experiences, and better collaboration between different stakeholders in the development process. For example, architects, engineers, and construction teams can collaborate more efficiently by leveraging the same data and insights to optimize overall performance. Here is an example of very simple web application utilizing both Autodesk Forge API and Azure IoT Digital Twins API to display BIM models from manufacturing process. The application allows the user to select a model of a factory line, which triggers a request to Azure Function microservice that extracts metadata from selected model using Autodesk Forge API. The metadata is stored in Azure Cosmos DB and used to map the entities of digital twin models. The user can view the manufacturing process 3D visualization with all real-time properties of equipment and its analytics. Now let's look into the key concepts of IoT digital twins that simplifies interoperability with real factory. So digital twins ontology is a set of concepts and categories that represent properties and relationship between different entities in a digital twin system. It's a formal representation of domain knowledge that serves as a common language for communication between different stakeholders involved in the development of digital twin. Digital twin ontology is needed because digital twin systems involve various manufacturing domains. These domains have their own unique concepts and terminology, which can lead to misunderstanding and miscommunication among stakeholders, development teams, and subject matter experts. Digital twins ontology provides a standardized vocabulary that can be used across different domains, ensuring that stakeholders have common understanding of digital twin system and its components, and applications use the common model to build its capabilities on top of this model. It allows systems to exchange data and information in the standard formats, reducing the need for custom integration and simplifying the process of connecting different systems. Furthermore, digital twins ontology enables the development of intelligent applications that can reason about the data and information in the digital twin system based on abstract interfaces. By representing domain knowledge in a formal and structured way, applications can understand the relationship between entities and make informed decisions based on that. Overall, a digital twin ontology is an essential component of any digital twin system. It enables communication, interoperability, and intelligent decision-making, making digital twin system more effective and efficient. Here's another example of energy grid ontology that defines structure of key grid components, like generation, consumption, transmission with underlying concepts of switches, breakers, meters, its capabilities, and its properties. One more smart city ontology represents just a fraction of hundreds of domain entities and containing properties. Microsoft team defined a huge set of standard domain structures, like for smart cities and other common domains. But for manufacturing, still there is no standard that fits any factory due to different processes depending on what product we want to manufacture on scale. I will not go deeper enough in the ontologies, but if you need blueprints and case studies that we done for other customers in electronics manufacturing, chemical plants management, car manufacturing, please contact us later after presentation. Technically, Azure IoT Digital Twin ontology are described in DTDL language. This is a standard Microsoft Azure language for describing digital twins. It defines how data of digital twin will be stored within IoT system and projected into the visualization. This very intuitive JSON format that allows developers describe domain ubiquitous language and share same model with all integrated applications. Here is one example of Azure Digital Twin implementation for existing factory. It requires a PCUA-based integration with SCADA system and some equipment via edge computing cluster managed by Azure Arc technology. This industrial solution provides a set of microservices that connected to a PCUA system. On the shop floor, the microservices API mirror the PCUA system functionality. Equipment control modules at the factory floor are implemented as Azure IoT Edge modules. Azure IoT Edge modules and Azure IoT Cloud services are available as pre-built Docker containers for deployment into this platform. Operations personnel can subscribe and react to events on the factory floor from anywhere in the world. Azure Industrial IoT will enable the reception of alerts and alarms and will allow reaction to them in real time. Okay, now let's quickly go through a couple of case studies we have done for our customers. So this one is our own IoT solution accelerator used by many of our customers. This accelerator can enable manufacturers to speed up their industrial IoT deployments and can cut time to market for their solution up to 50%. It supports common IoT scenarios, including remote asset management, built-in predictive maintenance, fleet management, and beyond. Cars predictive maintenance for one of biggest European car manufacturers. One more predictive maintenance for chemical plant equipment with huge cost optimization for our customer. I have prepared many case studies related to IoT digital twins for you, but time is running out, as I can see. So let's skip them for now, and we will share slides for you to find the relevant case for your business needs. But now let's go to questions first. Let's stop there for a moment. Intellias providing a wide spectrum of IoT services for full cycle enterprise IoT system development. And of course, it's not a full list of case studies we had done. So contact us for more details about IoT needs for your manufacturing company, or about any capability interested for you outside of IoT as well. So finally, I'm happy to answer any of your questions related to Azure Industrial IoT Digital Twins for manufacturing domain. We still have a couple of minutes for that.
Sorry, Serhii, I couldn't get my line back on the Zoom bridge. First of all, thank you ever so much for taking us through that last 20 or so minutes. Folks, by my reckoning, we've got about 7 minutes before the end of the allotted time, and about 13 minutes before, or 12 minutes before the start of the next session. So if you've got any questions that you'd like to have answered here in real time, feel free to punch those into the various chat boxes. You have the Zoom chat feature here, Q&A box, and you have our LinkedIn live stream page. I'm just opening up all the different applets here as we're speaking. Serhii, stand by.
Yeah, it would be good. It would be great to have questions maybe about specific case, so I can deep dive in some specific area for that. Yeah, because I have a lot of case studies, but it would be not really relevant for everyone to listen a lot of different cases. So it would be great to answer some questions that interested for our audience.
I'd say the first one here that's come through is talking about this the best approach for IIoT when it comes to digital twins versus intelligent assets.
So intelligent assets, if we're talking about inventory and assets management overall, usually that's a separate system for manufacturing, and digital twins, it's a ecosystem that works on top of a lot of business systems for supply chain management, for asset management, for IoT connected devices, and bring all this data in a kind of very big graph database, like big data warehouse that connects all of the data and processes, and it allows to get more insights than the regular asset management systems, and it allows to build better prediction models, better analytics, and data for training AI models as well, that has very big and wide model with different data from different processes, and can get insights that company might not even imagine without some IoT and AI merging technologies.
I hope that answers that question. So there's one that's coming here through the Zoom. I'm not sure if I'm going to read this correctly, but I'll give it a go. Cheers, Bob. Can you implement digital twins in digital tapestries into the auto industry?
So if we're talking about auto industry, car manufacturing, yeah, so we have built twins not only for manufacturing process and automation. We have twins for, as I presented, one of case studies for car predictive maintenance. Basically, every car that connected to nowadays sends a lot of telemetry as from a lot of ECUs on the car. So we built a digital twins of consumer cars and trucks, and predict maintenance of different parts of these cars. We analyze how these cars can be manufactured, keeping quality the same and reducing manufacturing cost for the company.
Hopefully that answered that question there for you. So folks, we've got about 4 more minutes before the official end of this time. So if you have any other questions, feel free to dig them in. Another one that's coming through here is talking about, are you only building on Azure or do you operate on other clouds as well?
Yeah, so as I showed, let me quickly go back a couple of slides. We have a lot of expertise in different clouds, not only Azure. So, for example, our industrial IoT accelerator allows to spin up it on Microsoft Azure, AWS Cloud, GCP Cloud, and of course on-premise. On-premise environments very important for factories, for manufacturing, yes, because all the critical process and safety processes needs to run on site. In case of any downtime of cloud platform, everything should work on the factory. Yes, so we have a lot of experience with edge computing and building on-premise systems as well that works on the Kubernetes on any platforms, not only Azure. Yes, but for digital twins itself, we have experience with different platforms also. So major one, of course, Azure IoT Digital Twins, but we have experience with Siemens MindSphere. We have experience with such platform as AWS IoT Core and AWS Digital Twins. And yeah, so different experience, AWS, Azure, on-premise. For now, it fits all our customer needs. Maybe if we will have some very special case, maybe we will build I don't know, IBM cloud capabilities or something else. Yeah, but our primary experience is Azure, AWS, and edge computing.
Okay, hopefully that answers that question for you. So we've got literally 1 minute left, folks, but I will just put this question out here because we've got this time. And another one's literally coming as we're asking that. But what's your view on build, custom versus off-the-shelf applications and software?
Okay, so there is no off-shelf software that fits like specific factory needs, yes, because every company produces their own products, and there is no product that covers everything. Yeah, so it's always a lot of off-the-shelf products, a lot of complex systems like SAP systems, some manufacturing control systems, systems for CNC and multi-axis machines and robots from other vendors, and all of that chemistry needs to be integrated together, and also a lot of software needs to be written from scratch for specific needs of that factory because it's not exist. Yes, so it's always takes some time to do assessment of systems available on the market, and we always do cost-benefit analysis for a client, comparing different strategies, what different companies propose and what we can build, and what's the cost-effective option for the client to meet business goals.
That answers that question. Thank you for entertaining that. Well, we've got about 5 minutes before the official start of the next session, and there's another couple of questions here that I'll try and get to as well. So we're going to go as far as we can with you here today, sir. I appreciate you entertaining some of these questions. This one's coming again through the Zoom interface. When higher speed GPUs are used with IoT analysis, how will this change the way you use digital twins?
If I understood the question, analysis of data based on GPU compute resources.
So I just pasted the question for you into the chat if you want to have a look at it.
Let me read that, because I'm not sure I got it.
And for any questions we don't get to here in real time, we'll come back to you offline, of course. But so go ahead.
So let me answer this question. So GPUs use it for very specific IoT analysis needs. So we had cases where we stream analog data from power plant and measuring vibration on the bearings of different turbines and engines on the power plant. And this requires a lot of computational algorithms to process analog data about vibrations. I'm talking about like 50 mega transactions per second. And for that purposes, we use ASICs or FPGAs or GPUs, depending on scenario. So this usually implemented on the edge computing. For cloud needs, it also sometimes required to process some big data, and especially for machine learning. Yes, but usually this computational not touching digital twins itself and its model. Yes, it touching some data streams, and it integrates with digital twin via digital twin APIs and providing results of computational results from the GPUs clusters to the digital twin model or to the analytics and applications that used by this platform. So yeah, hope this was last question for this presentation, and yes, contact me outside of presentation to answer more of your questions. And thank you all for your time, and feel free to contact me for more details.